Diagram above shows the force extension curve of a piece of wire full stop. The energy stored when the wire is stretched from E to F is, look at the diagram here. We have 0.2 Newton here, 0.1 Newton. We have P, we have Q, we have R. We have 0.05 meter on E. Then on F, 0.10 meter. And this side is the side of extension, while this side is the side of what? Force. And we have option A, 1.5 times 10 raised to the power minus 2 joule. Option B, 7.5 times 10 raised to the power minus 1 joule. Option C, 7.5 times 10 raised to the power minus 1 joule. Option D, 2.5 times 10 raised to the power minus 3 joules. Solution. We have to, we'll draw the graph again. We draw the diagram. This side is force, measured in Newton. And this side is extension, measured in what? Meter. Based on the diagram. And we have R here. Here is Q. This is the point. And we have P, point P here. So we have to trace this point. Here is 0.1 Newton. And if we trace this one, here is 0.2 Newton. Are you there? Now, draw the line vertical here. Draw this line vertical. This is E, and this side is F. Now shade this portion so that you know that this is what you are looking for. This is what you want to calculate in order to find the energy stored in the what? Stored in the wire when stretched from this point E to point F. So at this point we have 0.05 meter. While at that point here we have 0.10 meter. So we have to carve out this shaded portion here. If you carve it out, look at the way it look exactly in the graph. We shade it. When you are done shading this, so from here to here is what? Here to here is length, and from here to here is our height. Is that correct? And from here to here is our breadth. Is that correct? Good. So this is a trapezium. It is standing. So let's keep it the way it should be. Based on the way it should be like this. It should be like this. We have to indicate that this is a trapezium. So shade it again. If you shade it based on what you saw in the graph, remember from here to here is what? Our breadth. Are you there? And from here to here is our height. From here to here is our length. Do you understand? So the area of trapezium, the area of a trapezium is given by 1/2 bracket length plus breadth times height. At this point, this area of trapezium is equal to the energy stored. What the what? Energy stored in the wire. Are you there? So we can say therefore E is equal to 1/2 bracket length plus breadth times height. Are you there? So can I divide this place? Okay, this place will be enough. So E now is equal to, we have to state our diagram again. In this diagram, where we indicated the length, breadth, let's show, or can we do it over there?
Yes.
So that means our length here is equal to our length here is equal to what? 0. What? 0.2, and our breadth here is equal to 0.1. Are you there? And our height here our height here our height here is equal to 0. Here is height, right? Don't worry. Let me do it in a way we understand it clearer. Here is what? 0.05. Is that correct? How do we get 0.05? 0.1 minus 0.05. Is it correct? Now, our breadth here is what? 0.1. And our length here is what? 0.2. Is that correct? Now, shade that portion again so that we know what we are doing. So, E now is equal to 1 over 2 bracket. Length is what? Length is 0.2 plus 0.2 plus what? 0. What? 1 times height is what? 0.05. Is that correct? So E is equal to 1 over 2 times 0.3 over 1 times 0.05. So this is E is equal to 1 over 2 times 3 over 10 times 5 over 100. So E now is equal to 15 over 2000. I want us to reduce this thing. 5 here, 1, 5 here, 2. Is that correct? So you have 1 over 1 times 3 over 2 times 1 over 100. So E is equal to 1 over 2. Here is 1 over 2. So this is 3 over 4 times 1 over 100. 3 over 4 will give us what? 3 over 4 will give us what? 3 over 4 will give us 0. I want to finish up here. 3 over 4 will give us E is equal to 0.75 times 1 over 100 is 0.01. Is that correct? So E is equal to 0.75 times, this means 1 times 10 raised to power minus what? 2. Is that correct? So now, E is equal to, this 0.75 means 7.5 times 10 raised to power what? Minus what? 103. 0.5 times 10 raised to power minus, press 0.5 times 10 raised to power minus 3 in your calculator. What did they give you? What did they give you? 0.75 times 3 raised to power minus 3. What did they give you? You don't have calculator here. It will give you minus. So this will give you minus 1, right? Now times 1 times 10 raised to the power minus 2. So now E is equal to 7.5 times 1 times 10 raised to the power minus 1 times 10 raised to the power minus 2. Are you there? So E now is equal to 7.5 times 10 raised to the power minus 3. Because how? This is minus 1 plus bracket minus 2. So E is equal to 7.5 times 10 raised to the power minus 1 plus times minus 2. So E is equal to 7.5 times 10 raised to the power minus 3 joule. Final answer. So now answer is option C.